Hey friends, welcome. It's the India Azure Community Conference. We've got thousands of people that are joining live from all over the country, all thanks to the Azure user group communities across India that have joined forces, the MVPs and the RDs and the CNCF ambassadors, the women in tech communities. They've all come together and they've organized this wonderful conference to go and learn about the open cloud, about Microsoft Azure. I don't know about you, but I'm super excited because we've got 3 days, lots of tracks in this virtual conference, and there's so many great things for the experts to offer us and to train us. Right now, I'm going to talk to you about the joy of Azure. So I got to get into my zone because I got to give a presentation to thousands of wonderful people, but I'm actually all by myself here in my home. So I'm kind of imagining that you're here with me and we're going to learn a lot about the cloud. Here we go. Serenity now. Hey friends, I'm going to talk to you today about the cloud. You might have seen on my YouTube channel where I've talked about the physical aspects of the cloud, and I've shown you like what the cloud looks like. But I want to talk about software right now. I'm going to use Azure as the example, but it could be any cloud, because these are really about cloud concepts. There's a lot of cloud concepts that I think people are confused about. I think it's fair to say that generally the cloud is confusing. People do a lot of things with the cloud that I think are a little bit naive. I think that if you go to all the effort to move your things to the cloud and you just end up putting a machine that you had under your desk into a virtual machine in the cloud, you didn't really get any cloud benefits. So for a lot of people, the cloud is confusing. For me, though, I think the cloud is a joy. The problem is when we introduce the cloud to folks, I think that we do it wrong. If you ask someone to teach you Azure, or even if you met a Microsoft employee and said, hey, can you tell me about Azure? They might go and show you a diagram like this. They're going to be like, oh, it's amazing. Look at all this great stuff that we've got in Azure. We got this thing and this other thing. And then they'll start drawing lines. And they're like, look, and that talks to that. And then the thing with the people and the thing and the arrow. And it's completely nuts. We haven't taught people the fundamentals of the cloud. We don't think about the history of computer science, and instead we force people to memorize the names of all the different little things in the cloud without actually talking about the things one needs to understand to build scalable cloud architectures. So let's back up. There was a gentleman who had a wonderful quote. Thomas J. Watson from IBM said, I think there's a world market for maybe 5 computers. Now, for him, that was the computer that was like a refrigerator. You can see this lady programmer here who's working on this computer. And for Thomas J. Watson, that was the cloud. And there'd be 5 of them, maybe 1 per continent. The cloud in this context was just a room-filled computer because no one had ever thought about making a computer that would actually be small enough to fit on your desk. In this instance, the computer that this person is using is not a computer at all. It's a terminal. It's talking to the larger computer that she's programming here. So this actually kind of happened, didn't it? There are 5 computers. There's simultaneously billions of computers and also 5. There's the Azure computer, and then there's a Google computer, and I understand that there's a popular bookstore that has a computer. There's just a couple of them. They're just world computers. Azure itself is a world computer. And just like in the old days where they would pick up computers and they would drop them off the back of a truck, almost like a container truck or container ship, they do similar things, except now a computer could be expressed like this. If you went and looked at an Azure data center or an Azure region, that might be one right there. Let's say that that's maybe, I don't know, that's West US 2. And this is where I think things get really powerful. We, as developers, can just go into a web page, do a drop-down list, and we see West US, East US, West India, North Europe, and we pick one, and then somewhere inside of one of these warehouses in an Azure region somewhere, a little hard drive starts to spin, or even better, a little SSD starts to do nothing because SSDs don't spin. And I think that's a good place for us to start, because no matter what cloud you're using, no matter what system that you're building, you need to think about storage, you need to think about compute. So forget about the names of things. It's Azure Storage on Azure, it's S3 on Amazon, it doesn't matter. There's storage and there's compute. So the cloud starts there. In this little diagram that I'm going to start slowly building up here, I've got Azure Storage at the bottom. Those are hard drives. There's N number of them, where N could be billions. It doesn't matter. You have a giant infinite hard drive in the cloud. Then there's compute. And at its base layer, the number one thing that people use the cloud for is virtual machines. Just like a physical machine, except it's living somewhere else. The important thing to remember about virtual machines is that they don't know that they're virtual. That sounds kind of silly, but if you were to anthropomorphize your computer, if you were to think about your computer as if it were a person, this is a computer that's living in the matrix. It doesn't know that it's a computer running inside of another computer. Like maybe Azure runs Windows and your virtual machine runs Linux. It doesn't need to know that it's inside of a host. Just like Neo in the Matrix didn't know if he was inside the Matrix until his eyes were open and he took the red pill. So Azure Storage replaces this idea of physical hard drives. In the old days, I would have to go to an actual hosting place. I could actually visit my computer, the computer that I had rented, and I could find that physical hard drive and I could touch it. So theoretically, if I had a laptop and Wi-Fi and I could go and visit the host, I could put in Hanselman.com and press enter, and I could see a little light start blinking somewhere on the machine. I could visit the machine at the hoster that ran my website. In the world of the cloud, you can't do that anymore. My website, my blog lives on Azure Storage, which isn't one hard drive. It's N number of hard drives. In fact, when I used to copy things to my host, I would copy them onto a physical hard drive, and there was just one. And maybe they would back that hard drive up once a week, once a month, once a day. So if there was a crash, I could call them and they would restore it. But with something like a cloud storage provider, when I copy a byte into cloud storage, that immediately gets multiple copies. 1, 2, 3, 5 copies. Could be globally distributed if it is a CDN or a content distribution network. So I decided to take one tiny file and put it up in the storage in the cloud, and it now appears in some large number of places and finds its way all over the world. That's a fundamental thing we need to understand. Here's the other thing. For most people who are paying regular prices, not premium prices, that hard drive may be a little slower than the hard drive or the SSD that's sitting in your desktop. Additionally, depending on how you configure your cloud, the relationship between these two things, between this virtual machine and this storage, may not be a physical one. The computer that I'm on right now has a physical cable that I can touch. So when the virtual machine or the physical machine decides to put something on the hard drive, it goes over a physical wire. Here, we've got software-based networking, we've got fiber, we've got wires. I don't know if the storage and the virtual machine are co-located. So if I wrote some code on that virtual machine, which was going to do something very disk intensive, I have to think about where that storage is located. You would not want to be on a computer in Chicago and then having it talking to storage in Ireland, especially if it was in the middle of a really tight loop, I'll talk a little bit about that in a moment as I share with you how I moved my own personal website and my blog into Azure and how I had to deal with that very significant problem. So if virtual machines and storage are the building blocks, the base of the pyramid, then what kinds of things can we build on top of it? So in this example, as I add more boxes on top of the virtual machines and storage, we see Azure App Service or websites. And again, every cloud calls it something different. And on top of that, you run web stuff. Could be web apps, could be web APIs, doesn't matter. It's webby stuff, HTTP stuff. The virtual machines run those websites. Virtual machines are infrastructure as a service. That means I'm renting infrastructure, just like when you rent a truck. The app service, though, hides the operating system from me. So I'm actually renting a driver who brings their own truck, and I don't really have to think about anything. I just ask the driver to do things. I don't have to worry about my hard drive when I run my websites here. I don't have to worry about my virtual machine. I don't have to worry about my operating system. I'm running web stuff. The other thing that has come out recently, the last several years, is this notion of containers. Containers are, for some, largely a deployment technology, whether it be something like Docker or otherwise, and then you run web stuff. We'll talk a little bit more about that in a minute, but it's important to note that there's still a virtual machine. So even though you may hire a driver, and they may bring a truck, and they may do the job, and then the truck may leave, you don't have to think about the maintenance of the truck, the insurance, the mechanic that has to work on that truck. You just wanted some work done. So you get to think at a higher level as you move up the stack. But sometimes these things break down. So you might be on a website or in a container and something goes wrong, a blip in storage, a hiccup in a virtual machine, an entire region goes down. Then you have to ask yourself, is it your responsibility as the architect of the system to keep that site up, or is it an issue of an SLA, a service level agreement, where the cloud provider has promised that they will keep things up? 5 nines you may hear 99.999% of the time is about 5 minutes down a year, which is really, really hard, by the way. So you have to ask yourself, can I architect a site like this, a system, such that it could have 0 downtime? Well, it's still your responsibility. Even if the cloud provider says that they'll keep that thing up 100% of the time, it is ultimately your responsibility to make a site that is resilient. And I think a lot of people don't do that. So I'm going to try to offer some examples of why that's important. And I hope you're starting to get a sense of the tools that you have available when you use a cloud like Azure, but also the idea that it starts to become more than just virtual machines and storage. We're going to return to this slide and a slide like it in a little bit. Once you start having things like this in a tool like Azure, you can start to look at them, the context, the diagnostics, the observability. Look at these things in the context of a dashboard, just like you look at the dashboard of a car. Now, some people who are used to managing virtual machines, like myself, might have a machine or a physical machine under my desk, or I might have a Raspberry Pi like this one here on my desk, and I want to look at its CPU and its memory. So I would want to look at a dashboard. Well, I could use something like Top. Is that a dashboard? It's not really a cloud dashboard. It's a process list that's given to you by Linux, but it does give you some context about what's happening. Newer dashboards like HTOP start to be a little bit more sophisticated, but this again is only showing you the memory, the disk, the processes, the CPU that's happening on a single computer. I need to up-level my thinking. So I can look at something like this, which is an example of an Azure dashboard. And what's exciting about a dashboard like this, for me as a small business owner or a medium business owner, I can see things like server response time. I can see that my pages load in less than 4 seconds. I can see the server does virtually no work. I can see my costs over here, in this case $400, and I'll show you a way to make that cheaper because I do a lot on Azure. I can see average response time, memory percentage, all kinds of things that give me information. This is a true dashboard that is explaining the big picture about what's happening on my site. It also allows me to see tests, in this case for availability. Is the site up? And then it also lets me see a map of my application and the calls that my application makes to third parties, to databases. This dashboard, this level of observability was almost unheard of 20 years ago, because you would go into a hosting environment, you'd bring your own hardware, you'd rack the physical devices, and you'd spend a lot of time parsing through log files and trying to visualize what was going on in your application. So one important aspect of the cloud is that of observability, and there's a lot of wonderful log analytics and observability tools that are now becoming available to us in the cloud. But this underscores the importance of the difference and understanding the difference between just taking a VM and putting it in the cloud, what they call lift and shift, which is fine, but that's not a cloud native or a born on the cloud kind of an environment, because all you've done is taken the CPU and the storage, the virtual machine and the storage, and you've moved it into another room, into a warehouse somewhere, in this case, into the cloud. As you start breaking apart responsibilities, though, things get a little bit more interesting. And then you start hearing about terms like serverless, okay? And serverless is funny because it doesn't mean no servers. It means less servers. Another way to think about it is serverless means we think about servers less, okay? Gotta watch out. A lot of these cloud terms are meant to fool you and take your money. Serverless, think about your servers less. So let's look at our boxes again. Remember these boxes. We've got our storage at the bottom that everyone uses. Fundamental. Whether it's Azure or another cloud, the storage is important because your virtual machine, its hard drive sits on top of that. Your websites, your web APIs, your containers end up talking to that Azure storage through their associated virtual machines. So let's move beyond containers on the right-hand side there and bring in something like Kubernetes. Within Kubernetes or Azure Kubernetes Service or Service Fabric or one of the container orchestrators, we could then run on top of that functions, serverless functions, or you could take the Azure Functions Runtime, which is a Docker container, and you could run that inside of an app service. So you're going to run just a regular container in an app service. It's up to you. The higher you get above these virtual machines, you start seeing what might look and feel like duplication and what might feel like a little bit of repetitive naming. You can run containers on AKS. You can run containers on app service. You can run containers on Azure Container Instances. Again, trying to offer a lot of choice for those that want it. But don't forget, there's a virtual machine somewhere that's doing that. Even in an environment where you have what's called a premium serverless Azure function or a consumption-based Azure function, somebody somewhere fires up a container, keeps track of it. It's sitting on a virtual machine that someone is managing. And even though you're only billed per second, you're billed for the usage of that particular item, someone somewhere is updating operating systems. And by someone, it could be an agent, it could be a human, it could be Azure itself, it could be the fabric that Azure runs on. But storage still exists, virtual machines still exist, you just can't visit them. That's why the cloud is such an interesting thing. It's a mesh of computers. It's a world computer. I can then do things like static web applications that just serve HTML, but then they call functions or they call sites or APIs and things like that. Here's an alternative way to think about this. I've used the example of buying a car, renting a car, getting a driver to take you somewhere, maybe getting an Uber. Here's a great example that I've used for many years that was used, made by Paul Kerrison, and I've used by permission. And this is called Pizza as a Service. So let's take a look at this. You want some pizza. Traditionally, everything's on premises. This is how the legacy works. If you want some pizza, then you need to have a conversation. You need friends, you need soda, pizza, you need the fire itself, you need the oven, you need the gas, and that would be homemade pizza. And you'll notice here, you manage all of that. You have to supply every one of these things, and that's cool. And that's homemade pizza. As you move over to infrastructure as a service, the oven and the gas and the electricity that runs your oven, in this case, is provided by a vendor. That is vendor managed. All you have to do is bring the ingredients and the friends. So when I make a virtual machine in Azure, somewhere out there, someone fires up a computer for me. If I actually go into Azure right now, I'll take the Azure application and I'll bring it over onto this monitor. And I'm just going to say, create a resource. And maybe I'll type in, Ubuntu. And it says, hey, create an Ubuntu server. And it immediately pops in and it says, all right, let's do it. Let's make a virtual machine. We'll talk a little bit about disks and networking, but for the most part, all you need to really do is think about how fancy of a computer do you want? How big of a pizza are you looking for? Small, medium, or large? Okay? And someone is handling the creation of that for me. The physical hardware needs to be set up. That virtual machine needs to be provisioned, created for me, and then put into my control. That's infrastructure as a service. But I could move in the other direction here and start thinking about containers as a service, or maybe we'll say platform as a service. And you'll notice that as I move to the right, if we move, for example, to platform as a service, I don't want to think about that virtual machine. I don't even want to think about the pizza. I just want it made for me. I want to put up a website. I want it to be great. Maybe it runs Ubuntu, maybe it doesn't. I don't really care. Maybe it runs Windows. What I want is to bring friends. I want to bring my soda and conversation, and everything else happens automatically, managed by the vendor. So that's the thing that I've chosen for what I'm doing. I use Azure Application Services, and it hides the virtual machine from you. In this case, the pizza, the fire, the oven, the gas are all hidden from me. And then as we move farther and farther and farther over to the right, all the way out to software as a service, where that software might be Microsoft Office, or that software might be Azure Cognitive Services, or some AI service in the cloud, where I want to go and talk to something and I want everything handled for me. Isn't this funny? In this example, I don't even need any friends. They'll rent me some friends and I can have pizza and conversation and just show up. That's pretty cool. That's like going to a party. You just show up and there's food there already. Isn't that nice? So let's think about this in the context of Azure. We come back over here and we look at the things that I'm running. I've got the ability to run virtual machines. And remember, that sits on top of storage. But app service plans are what you run an app service in, or a web app in. If I click on an app service plan, we can see here that I have two of them. One is Linux and one is Windows. And I noticed something very interesting. We have a Windows one, we have a Linux one. I've got 3 applications in my Linux app service plan. And I've got 6 in my Windows. You can see the locations are different. And then I have 2 different pricing tiers. I have a very, very basic, cheaper Windows pricing tier, and in there I have put 6 apps. A lot of people don't think about this. If I have my application, my web application living in Azure, there is still a virtual machine underneath it. So if we look here, this app service plan must be a virtual machine of sorts. And as a virtual machine, it can run multiple apps. You'd be surprised how often I see people running just one app service plan with one app inside. That's showing a fundamental misunderstanding of how Azure works and how full it is. It would be like renting a car with 6 seats, but then only having one person sitting there. It's a waste of a nice car. So notice also the pricing tier, the basic one and the premium one. Let's go and click on one of these. And I'm going to click scale up. And I'm going to note over here as it loads the price that I've got a $32 a month computer with 2 gigs of RAM. That's a lot. I can do a lot with 2 gigs of RAM. In fact, I'm running 6 different websites here. And this is for less demanding workloads, but it works just fine for me. I'm enjoying it very much. There's nothing wrong with that. And in fact, if I can go over here and I can note that I'm doing all of that in 60% of the RAM, and my CPU is minimally spiking. So I could probably fit some more work on this. I've got 6 different applications all running on this server farm, 6 web apps running on an app service plan, which, to be clear, is still a virtual machine. It's just one that I don't have to think about. I don't worry about patching it, running into updates. It's handled for me. And that's the joy of something like this. So when you think, oh, an app service is platform as a service, there is still infrastructure underneath it that is required to make that work. So that's interesting. Let's go back over here and let's look at our Linux one. Remember that I'm paying more money for it. It has to do more work. My CPU here is at 12%, sometimes even higher. Looks like it's actively working and it's using about half of the memory. I've got 3 things running here. I've got my blog, I've got the home page of my website, and I've got my podcast. Even then, 3 sites of non-trivial traffic are all still managed on one app service plan. But I'm not, again, having to think about patching or managing the underlying operating system. Honestly, other than the fact that it's running on Linux, I couldn't tell you whether it was Ubuntu or OpenSUSE or what was going on there. And then individually, I can manage each application, and I can look at the application's health, response time, etc., and I can start, stop, restart, and manage these applications individually. That's really exciting. Also, the ability to do my deployment either from Git or GitHub Actions or from Azure DevOps. That has been incredibly convenient. So you can see a couple of weeks ago where I deployed to production. I can then go and click on the source version or the build and learn about what was the code that was put into production on that particular day. And that linkage is there. Additionally, things that I could have never have done easily are done for me, like these backups. It's such a small thing, right? Automatic backups. We take it for granted. But before, when I physically bought a computer and I racked it somewhere, I had to configure that. I had to think about that. This is where things, I think, get really philosophically interesting, and why I think it's so important to talk about dashboards, is that I am one person. I am one person, and I am not a business with multiple employees. I just have my blog and my podcast, and look, I have a professional dashboard that is showing me the health of my websites, whether it be my podcast or my blog. And I can look at this, see my availability, any exceptions that I might be having, my average processor time, as if I had an entire IT department behind me. As we think about the cloud and the power and the joy of the cloud, it is the ability for someone with a little amount of money to be able to rent something like this be able to exploit the power of the cloud to get all these great diagnostic tools without having to pay anything extra. Everything I'm using here is seen on a standard or basic app service plan using the most basic out-of-the-box application insights that are built with Azure. And I think that's really, really significant. I can go and look at the dashboard for my podcast as well. And it'll even go and zoom in and show me individual costs per resource, which is pretty cool. And I'll actually zoom in and I'll show you that as well. I pop into my stuff here and I can go and see exactly what's costing me money. I can then click on those, go and see the individual details. And then when I see the details of these costs, I can go and say cost by resource and go and see what's costing me. Here we go. And individually, look at this. Exactly the amount of data transfer in and out as I manage this. So I have taken the time a number of times and gone into my Azure bill and lowered it and lowered it and lowered it by just being aware of what was going on and saying, oh, I don't want to leave that SQL Server running, or oh, I didn't need that storage blob. That has been incredibly powerful. It's almost like self-service, being able to get this information. I don't have to call support. I can just do it myself, which is super exciting. So the cloud then is other people's computers, except in the context that I've described it, they are computers that I have control of. They are programmatic, they're programmable, they are elastic, they can grow and shrink as I want them. I can get really granular billing. Per second billing is super important. But I can also really squish stuff into the cloud by understanding what's underneath it. So if we return to our diagram here, and we think about what's going on underneath here, if I know that an app service runs on a virtual machine, because an app service plan is another name for a virtual machine, then I can return to Azure, look at my app service plan, note that it's a basic, note that it has still some headroom on its memory percentage, and I could ask myself, I'm not really using much CPU here, I'm memory constrained, how many more websites or small APIs could I fit on this? I could be costing myself or the company money, and I really want to run these things higher and hotter than you typically would. In traditional hosting scenarios, if you saw a memory percentage like that, you might say, wow, I'm not really comfortable having 60% memory here. But remember, not only can I scale up at any time and just pick a better option, I could scale up if my memory went too low. I could go from 1.5 gigs to 3.5 like that. I can also scale out. I could go and then just change the instance count. And this is a thing that I find as a person of a certain age, as an older person, to be absolutely fascinating. The idea that I can just drag a slider bar and I can go from one computer to 5 or 10 or 100 in a web farm by just attaching a slider bar to my credit card and being billed for it is incredibly powerful, because back in the day, that wasn't possible. The slider bar was attached directly to me. I would have to go and find that computer and rack it and hook it up and think about load balancers and things like that. Which brings me to another higher level thing. In front of, or on top of rather, all of this stuff that's happening are other services like Azure Front Door. Azure Front Door is actually quite extraordinary in my opinion, because the front door designer allows me to take front ends like this, like my Hanselman.com front end, and then map it to multiple back-end pools. So for example, the main Hanselman.com website is different than the blog, and they have different routing rules. That again is a level of sophistication that one would only see in the past with entire teams of people dedicated to managing something like a website. So if I go to Hanselman.com and look at my website, that is an Azure app service. We saw that that's running on Linux. In fact, I can zoom in down here and I can even see the version of .NET Core that it's running on. This is separate from the blog that I can click on, and you'll note that /blog, while a subdirectory underneath the top-level Hanselman.com domain, is in fact its own separate Azure app service, which I can go and see here in my routing rules. I can see that I can match patterns. I can map front ends to back ends and allow one to automatically be forwarded to the back end pool. Just the ability to do that in a form is absolutely extraordinary to me. We used to fly people in from other countries and from other states to go and configure this stuff for us. And now I run a global archive that manages all of this content on my blog. I find that absolutely amazing. That is all available inside of Azure, and it's just one of the many, many things that I think we take for granted when we click on all services. We should remind ourselves of the basics. Virtual machines, fundamentals, storage. Virtual machines sits on top of storage. App services sits on top of virtual machines. Things like Kubernetes, static web apps, Azure Cosmos, they may all use virtual machines, but they've hidden it from us so effectively that it doesn't really matter. And that's what's exciting about it. I can choose to create a SQL server as a service, when in the past I might have created a virtual machine and then installed SQL Server on it. And then that would have been an experience. The granularity at which we can work is extraordinary. I'll give you one last example before we move on. If I go and look at, for example, my blog, we saw this before, okay? And then if we say, for example, looking at the dashboard for the blog, that there was some failed requests. I could go in here and say, let's look at failed requests over the last 7 days. Look at a particularly busy time. Just moving around in here is amazing. And look at that. I can see, oh wow, what's going on here? Someone is trying to run the command prompt. Someone's trying to attack my blog there, and they're doing a post and trying to maybe do a common WordPress attack on my blog, but in fact my blog is not WordPress, so they're not succeeding, which is absolutely fascinating. Notice that I'm able to move around through all of this stuff, see exactly when it happened. Look at this. Isn't this fun, my friends? I can see that they're actually looking, they're probing on my blog for some PHP files that of course don't exist because my blog is not PHP. I can see the call stack down here inside of ASP.NET as it failed to do any of that work. I can see all of the telemetry for this entire thing and a rich timeline of exactly when it happened by the millisecond. Let's just take a moment and appreciate how amazing that is to compare this to going and FTPing log files. Absolutely extraordinary. So if we return back from our dashboard to here, we can then ask ourselves, what makes this possible? The bottom level, it is in fact still virtual machines and Azure Storage and all the stuff that sits on top of it. The cloud is other people's computers. It can be initially confusing, but ultimately it's just a wonderful joy. And I hope that you don't take things like this to heart and get overwhelmed. Think about the basics, and the cloud will in fact be a joy to you as well. Thank you very much. Whew, that's hard work. I hope that you enjoyed the joy of Azure and that you explore the cloud with your friends and your colleagues. Now, throughout the day, it's important to remember that we've got several sessions from community experts on various areas of the cloud: development, CI/CD, security, making applications intelligent, using cognitive services, adding in machine learning. I want to encourage you to stay curious and ask questions using the chat option that the platform has offered. Be sure to network with people on the networking floor. If the breakout sessions get you excited about a topic, you can go and check out hands-on workshops. Make sure that you join them for an in-depth learning experience. It's a great opportunity to interact with the Microsoft product teams, your local MVPs, or Microsoft certified trainers. Be sure also to share your feedback with the organizers of the event so that they can make it better next year and they can always improve, just like we want you always to improve. Make sure to keep up your learning, and of course, post-COVID, when this is all done, be sure to look for user groups in your city and join experts in person. Have a great time. It's a wonderful time here at the Azure Community Conference. Thank you for having me.